In the previous video, we ended up with these boxes of numbers. And the most important division here is between rational and irrational numbers. Within the rational numbers, we saw that we have a box with the integers, and within the integers, we have a box of the natural numbers. But what unites all of these numbers here in the left, in the rational part, is that they can all be written as fractions of two integers. But we can also recognize them by how they look as decimal numbers, and that is the topic of this video. You may know already that pi is an infinitely long number, and that is precisely why we call it irrational. An irrational number has infinitely many digits without repetition. So pi, for example, starts like this. And of course, sometimes the same digit or the same two digits perhaps may turn up a few times, but there is no pattern that keeps repeating. So if we start writing pi as a decimal number, we will literally never be finished, not even if we use all the material in the universe to write with. So usually with irrational numbers like pi or the square root of 2, we just stop after a few digits. But they do go on forever. Now, fractions of integers behave in a nicer way. Sometimes they are simply finite decimal numbers, so negative 3 over 2 as a decimal number is negative 1.5, and that just stops. The rest here is zeros. And sometimes they are also infinitely long, but they are much more predictable than irrational numbers. Negative 4 over 3 is the same as negative 1.33333333, and so on. The 3's simply keep repeating. So we can quite easily compress this decimal number by using this overline, also called a vinculum, Latin for a chain or a tie, because it keeps the number from exploding, basically. So if we place the overline over a digit like this, that means that digit keeps repeating forever. And if we place it over a group of digits, then it means that that group of digits keeps repeating forever. So here 2.2857114 with this overline here actually means 2.285714, 285714, 285714, and so on and so on. So I told you just now that rational numbers have these infinitely repeating patterns and irrational numbers don't. So that means that all of these numbers are rational, and that in turn means that they can all be written as fractions of two integers. And the final part of this video will be what I think is a very elegant technique to find that fraction. So given a number with infinitely repeating digit patterns, how do we find the corresponding fraction? So let's take the number 1.33333 with the 3 repeating forever. And maybe you already immediately see that this is the same as 4 over 3. But in a more complicated situation, you might still be interested in knowing how you would get this result. Now, the trick is as follows. We take this number with all the repeating decimals, and we call it x. So the question is now, can we write x as a fraction? Now, to prepare, we first multiply the number by 10. So we get, in this case, we get 13.33333, and because the 3's keep repeating, we can write the two numbers above each other like this. Well, 10 times this number is the same as 10 times x, so this number is 10x. The next step is that we subtract the smaller number from the larger one. So on the left here, that means that we get to subtract all these 3's from all of these 3's. 3 minus 3 is 0, 3 minus 3 is 0, and so on and so on. So to the right of the decimal point, basically all of these digits become 0. And to the left of the decimal point, we get 13 minus 1 is 12. So we get 12 here. Now what we did here was just take 10x and subtract 1x. So this number that we've gotten here is 9x. And that gives us a simple equation. Because now we just have 9x is the same as 12. And we can solve this equation for x by dividing both sides by 9, and then we get x is 12 over 9. That is already a fraction, But let's simplify it by dividing the numerator and the denominator by 3, and then we see that our fraction is 4 over 3, or 1 and 1 over 3. That's very elegant, right? So let's try this trick again with another number. You can try it yourself first, or you can just watch the solution now. We want to write this number where the 181818 keeps repeating. We want to write it as a fraction. Again, let's call this number x first. And now we want to multiply it so that we can write a new number above it where all the digits after the decimal point are again 18181818. In this case, the repeating pattern is 2 digits long, so we'll have to multiply by 100 to get there. So we multiply by 100 and get 618.181818. And we call this number, well, this number is now the same as 100x. Now let's subtract these numbers. So we subtract these numbers, and that means we do 8 minus 8 is 0, 1 minus 1 is 0, 8 minus 8 is 0, and so on. And then on the left of the decimal point, we get 618 minus 6 is 612. What we did now was we subtracted 1x from 100x, so this number is the same as 99x. So this gives us our equation. 99x is the same as 612. So we want to solve this by dividing both sides by 99, and that gives us x is 612 over 99. So the final question is, can we simplify this? Well, yes, both numbers are divisible by 9. There's actually a nice trick to see this. If the sum of the digits of a number is divisible by 9, then the number itself is divisible by 9. So we can check easily. 6 plus 1 plus 2 is 9. So 612 is indeed divisible by 9. And 9 plus 9 is 18. That's also divisible by 9. And the result is, let's see, 630 divided by 9 is 70. But this is 18 less. So, and 18 divided by 9 is 2, so the result is 70 minus 2 is 68, and 99 divided by 9 is, of course, 11. So we get 68 over 11. We can take 66 out of this, and then we get 6 and 2 over 11. And that is our number written as a fraction.